All right. Let's see. Okay, recording's going. So in this video, I'm going to go through some stuff about running post layout extraction using Calibre and running post layout simulations. There's a guide that should be provided to you on the course webpage, or if not, I'll make sure to provide it to you. It goes through steps on how to do this. However, I think our cadence has been updated some, and the Calibre rules that we're using are quite old. I think I saw the last time they were updated was in 2000, so it's like 25 years ago now. They might have been updated since then, I'm not sure. But the point is, there's some issues that have arisen, some different errors that pop up when trying to run PEX using the normal instructions. So this video is just going to go through the process and specifically focusing on how to resolve those issues. So the first thing you're going to want to do is close your cadence. Go ahead and do that. And then I need to copy some files. So right now I am in, let me make this bigger just a second, so you can see it easier. All right, there we go. So right now, okay. Right now I am in this directory where I run my cadence from for the TSMC180 RF PDK. So what I need to do is, and you can do this in your, sorry, getting tripped up. First, I'm going to make a new directory. So I'm going to call this PEX instructions. You can call it whatever you want, but just make a folder in here that you're going to put your PEX stuff in. PEX is parasitic extraction. And then next, you need to navigate to this directory. You can do this in your file explorer if you want, or in the terminal. I'll use the terminal. So it's remote cadence lib TSMC018 Calibre RCX. So you're going to go here, and if I list the files in this directory, you'll see there's this Calibre RCX rules calview.cellmap, and the error right now is that this Calibre RCX file references this rules file, but it doesn't do so correctly, and so it errors out. So the way around this is that we're going to copy these to our PEX location and then modify them. So you can copy calibre.rcx to your directory. So for me, that was tilde TSMC 180 PEX underscore instructions. So I'm going to go ahead and do that. And then I'm going to also copy the rules. I should have named this so something's long. Okay. Copy the rules file there as well. And then lastly, I'm also going to copy this calview.cellmap. Okay. So basically you need to copy all these files, this file, this file, this file, to wherever you're going to, whatever folder you create for your PEX. You can do this, again, in the terminal or in your file explorer. So now I'm going to change directories back to the PEX file setup. And I'll list the files here. Oops. And there you can see my 3 files. Now the next thing to do is make sure you know, get this directory, this path here. So I'm just going to use this pwd to show the path and then copy it. And then open the calibre.rcx file to edit it. So I'm going to use the gedit command to open it in a text editor. And then you're going to use Control F and search for rules. And that's going to bring you to this line here where it says include /rules. And this is the line that's being problematic. So you can just comment this out and then add a new line, include, paste the path where you stored the rules file, and then add rules. And that's basically just going to explicitly tell this file where to find the rules. Whereas before, this // was a little bit not communicating what it needed to. So I'm a little tired, so I'm just kind of struggling here. All right, so save this file, close it, and then now go back to where you start Cadence. So for me again, that's in this directory. And then you need to, let me find it, type in, set this environment variable, this MGC FDI.OA version. So you type in this export space capital MGC underscore capital FDI underscore capital OA underscore all caps version equals in quotes 22.60. I don't really know the details behind this. It's just if you don't do this, you'll get a fatal error. So this is something another student found at one point. So do that. Once you've done that, so you just enter that or type that in, hit enter. Now you can start your cadence again. Okay, and then let's see, I'm gonna find my example. Okay, so here's my completed layout that is DRC and LVS clean. This is for a 5T op amp, current mirror load op amp. And so I'm gonna go up to Calibre, run PEX, and then I have a rule set already set up. You can set this up according to the like PDF guide I'll attach, but the important thing you need to do is here where it says rules file, make sure you point this to that calibre.rcx file that we copied and then modified. So make sure it points to that modified one. And the other thing is, I don't know if it's specified in the guide, but make sure under PEX netlist that it's Calibre view and that you use source names here where it says use names from. So otherwise you'll have some issues. But with that, you can set up the rest of this stuff according to the guide. I've already done that, so I'm going to run my PEX. And this is just going to take a little bit of time to run. You can skip ahead a few times if you don't feel like waiting. It's probably just trying to get the CPUs to use for it. All right, now it's running. Man, it is running so slow today. I think yesterday I ran this and it took like 10 seconds. It was done. There must be a lot of people on the VM today. Okay, so once it's done, this window will pop up. And what you need to do is in this, I think this is talked about in the guide, but I'm going to point out some important things to do to keep things nicer, in my opinion. So in this cell map file, you want to browse and find the file that we copied. So, wow, this thing is terrible, File Explorer. So I put it in PEX instructions and then calview.cellmap. So select that. And then where it says Calibre view type, do schematic. Make sure to check create all terminals. And then I like to do a RAID or else it's really hard to find things. So a RAID just makes a nice clean schematic. Layout location, you can mess around with this if you want, but I do array. And then we'll do open Calibre cell view in edit mode here, just to save us a little bit of time. Oh, and you can name this whatever you want. Usually the default is just Calibre. I'm going to name it Calibre underscore demo. Just because I already have a Calibre file created. So, okay, and that'll run, and then it'll pop up in this window. It's going to give you probably a few warnings. You can just close this, and it's going to open the extracted cell view. So if I look at the warnings, if you get quite a few warnings, it should be okay. But my warnings are that my it has to do with my terminals not matching anything on the symbol. So I'll show you what that is here in a sec. So if you zoom in, you'll just see a bunch of components. So here's a bunch of parasitic resistors it extracted. If I go up, there's probably somewhere there's probably capacitors as well. If I zoom up, it's probably at the top. Yep, here we go. If I zoom to the top, it'll show all the pins. And if I look at my if I open my main schematic here, you'll see that on my schematic, V out is an output, VNN is an input, VNP is an input. Whereas when Calibre extracts, it just makes everything input output. And so if you try to run a simulation with this, it's going to error out and be like, netlisting fail because things don't match up and yada, yada, yada. So you just need to go through on these pins and change them. So VNP needs to be an input, VNN needs to be an input, VV2 is fine, VSS is an input output, but it's type ground. Over here, it's type signal, so change this to ground. This needs to be an output. Oops, output. And this needs to be a type power. Okay. And now if I check and save, should get no warnings, but I guess I am. What are the warnings? Oh yeah, and then also, whoops, I think I forgot, is that it makes everything capitals. So, and this is why you check your warnings. So V out over here is lowercase, over here it's uppercase. So I just need to rename that and then rename, delete these little warning things. Rename that and rename this. Okay, now if I check and save, I get no warnings. So that means everything's good. I can close this. And then now I just need to simulate. And I think the guide tells you how to simulate it. So you can just go do that if you want. I'm going to show you a little bit different way that I prefer, mainly because it's something that's can be used for different fancier simulation setups, and it's kind of a bonus if you know it. So what I'm going to do is I have my small signal gain bandwidth test bench here. And I think, where'd it go? Oh wait, no, is this the one? I have several of them because I've been playing around. Okay, this is the one. So I'm going to delete this. Show you. Okay, so what I'm going to do is go File, New Cell View. And for my test bench, which is this cell, I'm going to create a cell of type config. You're going to see it's going to open with a hierarchy editor. Click OK. That's going to open this window. Click this Use Template and then select Spectre from the dropdown. Click OK. And then under View, don't use My View. Use Schematic. Then OK. And then it should automatically create all this. You'll have this list of things. You can recompute this if you want to using this button. But basically what this does is it lists all the cells in your schematic. So capacitor, DC voltage source, the op amp, all this stuff. And it lists what type of view to use. And so your views are like this Maestro schematic, stuff like that. And so if we want to run post layout simulation, I can right click on the op amp. Under Set Cell View, select my Calibre demo view that we created using Calibre PEX. And once that's done, I can click this little paper with a check mark, click OK, and it'll save everything for me. So I'm going to set this back to schematic for now. Recompute it, OK, saved. And then I'm going to open my Maestro view. And then you're going to right click on your test here and click design. And then here, rather than having this set to schematic, which is like the default, set it to config. Hit OK. And then I'm going to go ahead and simulate. So it's going to simulate using the schematic view with no parasitics. All right, and it simulates. My gain bandwidth is good. My DC gain is good. And I'm not going to close this. I'm just going to minimize it. And then I'm going to change this replace to append. And then I'm going to open up my config view for my test bench. I'm going to click no here because I don't want to open the schematic. I just want to open the config view. Okay. And then on my op amp, I'm going to right click, set style view, and I'm going to set it to the Calibre demo view that I made earlier. Click this little paper with the exclamation point. Okay. Everything's saved. I can close this now. Now I'm going to go back to my test bench, and with this set to append, I'm going to run it again. And then I can open up my waveform again. And now it has the gain. I'm going to delete the gain ratio. I don't really want it. Just the gain dB. Okay, here I have my gain in dB from the schematic simulation. And here I have it from my post layout simulation with all the parasitics involved. And you can see it's pretty much identical. There's a little bit of difference. So it looks like parasitics had very minimal effect on this op amp. Looks like you can see the effects a little more here. And if I look at my calculated values, here I have my schematic ones, pre layout. And here I have my post layout. So it looks like my DC gain was not affected at all. And my gain bandwidth dropped by about 200 kilohertz. So some additional parasitic capacitance was probably added, which dropped that down. But yeah, so that's how you do it. If you have any questions, shoot me a message, shoot me an email, and have a good day.